Welcome to the Network Scalability module. This module, we will be talking about scaling our vSphere environment for networking. The features and the functions of the vSphere distributed switch are there to help you scale your networking. In this module, we're going to have 4 lessons talking about the vSphere distributed switch. We will talk about creating vSphere distributed switches in the first lesson. Then in the second lesson, we'll dive into managing our vSphere distributed switches. In lesson 3, we'll show you something called network out of control. And finally, discuss NetFlow and port mirroring in distributed switches in the last lesson. How we see this module is essentially, let's go through the basics in our first lesson. How do we actually create a distributed switch? And then learn about all the features that the distributed switch offers. In fact, some of the critical day-to-day features that everybody can use no matter how they use their environment is what we cover in the second lesson. That third lesson sets up quality of service capabilities that you get with network out of control. And finally, some additional features where not every customer may be using NetFlow or port mirroring, but if you need them, they're there, right? Things that you might find useful in your physical switches, we also offer in our distributed switches too. So let's take a look at our first lesson here, right? Creating a distributed switch, and we'll do a demo to show you the process. In this lesson, we'll show you creating a distributed switch, but also describe what distributed switches are, how they are different than a standard virtual switch, identify the benefits and the features of distributed switches, and also recognize how NSX virtual distributed switch is supported in vSphere 7, a brand new feature added to vSphere 7, and also in the latest version of NSXT, version 3.0. So, distributed switches. If you're familiar with a standard virtual switch, something that if you attended the vSphere Install, Configure, and Manage course that we would take before coming to this class, that class covers how to create and manage standard virtual switches. The architectural design is quite different with a standard switch as opposed to a distributed switch. Standard switches are essentially a host-based object, whereas a distributed switch is a data center related object. That's a whole other type of way of managing the network. Now, in both cases, they're providing the core layer 2 network capability with the standard levels of giving access for the VMs to connect to the network through the concept called a port group. That all remains the same. But the fact that if you happen to have, say, 50 ESX servers, and say each ESX server has 2 network adapters, right? Well, already you're knowing that's 100 network adapters. But what if the ESX server is actually connected to 2 different networks on 2 separate virtual switches? Well, now on an environment with 50 ESX servers, that's 100 standard virtual switches. That doesn't scale very easily, especially if you need to make a change. That would have to be changed on all 50 of those hosts. That would need to be at least 50 changes. And you'd have to make sure that was a consistent change without any user error, right? A distributed switch, on the other hand, is central. You build it at the data center level. The ESX servers join the switch, and then you basically build the switch at the data center. The complete virtual switch is then propagated to every host. So now you have guaranteed consistency. If you need to make a change, you make the change once, and it's pushed to all the hosts for you automatically. You don't have to worry about making independent changes on individual hosts. So that's really the selling point here. Distributed switches simplify data center administration. Another big point is the second bullet point. Networking statistics and policies can migrate with the VMs during vMotion. So what does that mean? Well, with a standard virtual switch, the switch ports are all managed and maintained by the individual ESX server's own VM kernels. And they're ephemeral in the sense that if a VM was to, say, migrate to another ESX server, it's going to have to join that ESX server's virtual switch. It's going to get another switch port, right? So if you wanted to create any kind of port-based policy, that is, when a VM is on, or I should say, if you're taking a look at, say, port 100 and say, okay, I got a MAC address, an IP address, and a port, and you want to create a policy based on that, it's impossible with the standard switch since the VM, when it moves to another host, is going to get another switch port. But it's actually even more than that. If you reboot a VM on the same host, it's actually going to get a new port because the VM kernel just assigns new ports whenever there's a power state change too. Suspend and resuming a VM gets the VM a new port. Even snapshotting a VM gives a VM a new port. So basically, having statistics and policies based on individual ports is not possible with a standard switch. But with a distributed switch, that's different. VMs there get assigned statically assigned ports. even if the VM moves to another ESX server. This logical switch essentially is, hence the name, distributed across all the ESX servers. The logical ports that are assigned for the VMs follow the VMs wherever they go. So if a VM migrates to a new host, if it was assigned port 100 on host A, it moves over to host B, it's going to still keep port 100. If you reboot, of course, it's going to keep the same port. So you have a much more scalable and also more granular way to manage your policies. And in fact, taking a look at just the design of this, you have data center level administration. That's the vCenter level control plane, right? When you build a distributed switch, what you really are doing is you're setting this up in the data center at the control plane level, where you'll set up port groups and VM kernel ports and even uplink port groups. We'll take a look at what that means in a second. What happens though is you build this configuration in vCenter. vCenter then propagates all this to the ESX servers into what become hidden standard virtual switches that can't be managed on the hosts. They're hidden from administrative view because they are designed to be centrally managed by vCenter. However, the ESX servers are the I/O plane. So all the networking is still being handled by the ESXi hosts. All that vCenter is doing is providing the configuration of the network for those virtual switches. However, when I said take a look at these uplink groups, one thing that's pretty interesting is that while you have port groups just like you normally would have port groups in a distributed switch as well as with a standard switch, but with uplinks, you basically are mapping the uplink connections on the physical server or on the ESX servers as they map into this distributed switch. So say, for instance, on every host you have VMNIC 0. If you've cabled all your ESX servers identically, all the VMNIC 0s should be mapped to the same network. So basically what you would do is you take all the VMNIC 0s and map them to a common uplink group on the distributed switch, like we happen to have here, right? Here, this might be VMNIC 0. This over here might be uplink 0 or VMNIC 0. They both are connecting here to a common uplink group. By the way, you can call that uplink group whatever you want. It's going to be called uplink group 1. But you can call it whatever you want. If this happens to be the network that your management network is on, you could actually call this the uplink group. You call that the management uplinks because it's going to VMNIC 0 on both hosts. That's the management uplinks. That would be mapped to your management ports that are on that distributed switch. Maybe this port maps to vMotion on this host and on this host. They're both going to the same uplink group. I can map my vMotion port to that uplink group and call it the vMotion uplinks, so I know already it makes this easier to map things correctly. Maybe my third uplink here, VMNIC 2, is mapping to where our VMs are going. So I have this uplink and the third uplink on this host. They're both going to this uplink group, which then might be called the VM data uplinks. And so then I can make sure my port groups are mapping to those. This makes this so much easier. Instead of having to just look at numbers that don't always mean anything to everybody, having actual descriptive names that help point and configure things for us. So distributed switches tend to be a lot more intuitive to use and to manage. And they obviously, with their centralized management, can scale to configure for very large environments. And they also have a lot more features. I mean, sure, they share a lot of common characteristics with standard switches, such as these, right? It's a layer 2 switch, it's providing VLANs, it's providing 802.1q tagging, NIC teaming, and so on. All those features remain the same, but distributed switches, they've been around since the vSphere 4 days, and every update since vSphere 4, there's been an update to distributed switches features. Standard switches, not so much. So thinking of the additional features, it's a much larger difference here, right? The distributed switches offer all these features that standard switches don't have. I'd say a lot of it boils down to two main things that we already talked about. Data center level management is a key characteristic because it is a data center level design, and you have per port policy settings. That's another really big thing that gives you that granularity because everything else kind of stems from that. Things such as the ability to have vMotion following a migration of a networking state. The VM gets assigned a statically assigned port, so you can have a policy that follows VM wherever it goes. Network out control lets you set up prioritization on a per port basis. You get your per port policy settings, port state monitoring, being able to monitor with a network sniffer on a per port basis. So you get port state mirroring and monitoring, NetFlow support, and of course, there's all these other things such as inbound traffic shaping as opposed to just outbound, which is what you get on a standard switch. You have the ability to back up your configuration. This is great for in case you want to have a safety net, you're going to make a big change to the switch, back it up beforehand. If you make a change that makes things go wrong, at least you had a backup, you can roll it back. So a lot of really powerful capabilities that you get with a distributed switch, and the list just keeps on growing every update to vSphere. So we'll take a break at this point. We'll come back and perform a demonstration to show you how to create a distributed switch. So stay tuned. We'll be right back, and we'll see you after the break is over.